And then we are ready to start with the first tutorial for today. Here's just a quick overview about what we're going to do in the next few hours. First, I'm going to talk about the requirements you would need to your hardware to use OpenDS. We are getting started with the software. We are running binaries, so you won't need any programming skills at all. I'm going to show you a little more about the assets. So these are the model files, the sound files, textures, whatever you need to set up a scenario. And then we will go into detail with the task description files, how you can implement your driving task to set up such a scenario. Then I'll show you what I've already mentioned in the morning, how to convert an existing model. So we have a simple city model that has been created with the city engine. It's available in the wavefront object format, and we're going to load this to the Blender and export it to OpenDS. Then we will gradually extend the scenery, set up sky, some signs, apply weather, and other driving cars. And last but not least, we will add interaction to our scene, and I'll show you how to use the drive analyzer at the very end. So first of all, the requirements. The software should run on almost any operating system. I've seen some of you are using Macs, Windows, some of you with a Linux device. No one? Okay. Is here anybody that has no experience with running the software? Only one? Okay, but it's no problem. We will we'll go through step by step, and hopefully we will get it running on all the computers. You should have at least 40 megabytes of memory for the JMonkey engine, plus the memory for the assets. So this will be a lot of more for the larger models. So as they might have a file size of, let's say, 400 megabyte or even more. So the experience shows that computers that are, let's say, not older than 3 years perform with our simulator. And of course, you need to install a Java runtime environment. I recommend the newest one, 7 or higher. Yes, as already mentioned, for this tutorial, you won't need any programming skills at all. Okay, I think some of you have already did the first task to copy all the files to your hard disk. For those at home, you can download them from this given address here. And at home, you would have to extract this file, and then we will go through. So you all finished step 1. Everybody has the system running. So then I do this in parallel here on my computer. I have the same folder that you should have. So if you now go to your file system, there should be a folder. You can just follow me. I'll try to guide you through. There should be 3 subfolders on your flash drive. At the moment, we just need this OpenDS software. So we go in here. There you will find 3 subfolders. The one that's called binaries, this is what we will need in the morning. And for the second tutorial, we will need this folder sources. So as you can see, these folders are not that big. The sources and the binaries, each of them is around 100 megabytes. The big folder is the assets folder. You see it's 770 megabytes. And to store, to save resources, as the assets folder is used for both, we will just copy it to the one we need at the moment. So at the moment, we just move the assets to the subfolder binaries. Strange behaving here, maybe because we have video recording. And now I just moved this assets folder into the binaries. So if you did this as well, we can move down to the binaries where we see the software now. Here we have the OpenDS libraries that are needed to run the software. This is the executable where you can start the simulation from. And the assets folder, which is also very important, we have all our models and textures and stuff that is needed for the visualization. Okay, if you've come so far, you can try running OpenDS by double-clicking this OpenDS jar file. And if everything is doing well, you should see this screen now. Then you can go through your settings here. For just testing, we won't need full screen, but you can select any resolution here. I think this is just fine. And some other settings here. If you have a performant computer, you can even enable anti-aliasing. But for testing, this is just fine. Then you click OK, and you get to the screen where you can select from some predefined driving tasks. So let's start the tutorial. This is files we are going to work with. And you see in the folder tutorial, there are 5 other XML files. We will fill them step by step now. You see there are 4 files called interaction, scenario, scene, and settings. And the 5th file is only there to start the project. And this is the one we select and click to start. If you select the wrong one, you will be notified and it's not possible to select any. And then you're in the model, it's empty. So you can see this screen. This is not defined. You can close this again and proceed with the slides. Yes, you can close it. We will gradually fill this scenario. You now have seen it's totally empty, and step by step we will place models into our scenery and rerun it again later on. By the way, this is how to get around. You can just use the arrow keys to control the car, the V key for changing cameras, and the escape button to close it again. Okay, now let's have a closer look at the assets folder, which we just copied to the binaries. It has some interesting subfolders, which this schema of these names of the subfolders are partially given by the JMonkey engine. So these are required. If you change their names, this might cause conflicts. So maybe the most important one is the scenes folder. This is where you place all your models, your driving environments. So this is the place where you find your city models and all the scenery you want to drive through. Then we have the models folder. We store their models in the same format, so it's no difference between scenes and models. Actually, it's just a convention that we differ between scenes and models. Models is just something you place in your scene. Model would be a traffic sign or something that might change over time. In your one scenery, you want to have a traffic light. In the other one, you might use the same global model, but you want to have a stop sign. So this is difference. We have the scenes for the global models and all the objects we want to place there. I would recommend to store them in the models folder. Sounds is self-explanatory. Store there some audio files if needed. You can also store custom files that you load. You want to play back in while driving. We have a folder for textures. The interface folder, where we have definitions of how our graphical user interfaces look like. For example, as we started the simulator 5 minutes ago, there was this driving task selection graphical user interface, and this is also structured as an XML description of how this interface looks like, and this is stored in the interface folder. And then there's another one called Jasper reports. This is where we can store definitions of how the output of some driving tasks will look like. For example, from the experiments in the JDOME, you got this bar chart of your reaction times at the end, and these templates will be stored to the Jasper report. All assets are stored centrally. You see, we use them for the binary files, we use them for the source code files. So this allows us to use them for several tasks. We just reference to these objects which we want to use. And this leads to the most important folder, which is the driving tasks folder. There we store only text files that are small in file size, and we reference to the models from these other folders. So we pick a scene, place 5 or 10 models, whatever we like, and arrange only the positions. We have only these text files, bringing all them together, where we define which sound files to use, which textures to apply, and use the other folders there. So just can go there. So we have a look at the assets in more detail. So you see this is exactly that structure. Yeah, maybe let's go just to the scenes. You see there are model files. Let's just pick one. In these model files, there are usually some text files describing the triangle structure of this model and some textures that are applied to this model, which is shaping our scenery. So here, this is just a small marketplace where we have some roads and there's some buildings, and all this is described in this scene file. So this is just one model consisting of several files, but closed in itself. We can now create this driving description file where we just reference to this sub file, this main scene, where we describe we want to use this town. Now I went up again to the main assets folder to go into models to show you the difference. There we have a folder where we have all our cars. For example, driving cars. This is the list of cars you can choose from. These are available. If you want to change the car, you would just need to change the reference to this car. So the path actually is needed, and if you don't want the blue one, just change the name and use the green one, for example. This is also the place. Now I went up again to the models folder, and this is also the place where we have our road signs. We have a comprehensive set of road signs in our release. They're grouped by their how they look like. For example, blue signs. There are some of them, and you can have a look into. By seeing the texture, you will already notice what sign this is. And here it's just the same. There's always a scene file in each leaf folder, which has to be specified in order to use this model. Okay, now I go up again to the models folder. Yes, we have a question in the room. Yes. The question was if it's possible to create new road signs on your own. That is possible. You could do this in two ways. The easiest way would be to use an existing one and just replace the texture. That's if it has the same shape, of course. And the other approach would be to use some 3D graphic tool and create your own mesh, apply texture to it, and then you can export it from Blender. We have so this is the way how these the master road sign has been created, and it was then exported. What we would see, by the way, later, how we can export models from Blender. Okay, now let's get back to the slides. We have seen that there are different folders. On the next slide, I just go into the subfolder of the driving task. Maybe let's first have a look here. I go now up to the main root of the assets folder again, and we will have a look into the driving task folder here. There we have two important folders. First one is projects. For every driving project, you would create a new subfolder to this one. And the other one is called schema. If we have just a look into it, it contains XML schema description files, which help you to formulate these XML files. And if you use a smart editor, you will be noticed if there are some errors in the code you produced. So you can use auto completion if you have these XSD files and use this highlighting of errors. So this is very helpful. Now let's have a look in the projects. You can see for each task we could choose from before we have folder. This is actually the point our simulation starts. It's a view of this folder, and what we do by selecting one of them, if we previously selected a tutorial, we go down into this folder, and here again are the 5 files I showed you before. These are the driving task files, the upper 4, and that tutorial is just a text file. We can have a short look into it, which is describing where the other files are. So if you don't want to stick with these names, you can call them whatever you like, but you will have to adjust the file names here as well. So what you start is this one, and the simulator is looking up where your scene information, where the scenario information and interaction information are stored. And after that, the simulator will load in this order the other XML files. So most interesting will be the upper 4 XML files, and this is what we're going to do in this tutorial. We will fill up these 4 files step by step in order to create a driving environment. So what we see on this slide is what I just explained. We can now move on. Here are these 4 important files. Every project consists of these files. And in short, here's a list what all these files are about. Very important is the scene file, of course. There you store the references where you find 3D objects, where you find the scene models. You can imagine that you provide the URL to this model you want to use. You can set this model to any position in your 3D space. You can rotate it, or you can make it larger by scaling it. You can assign masses if you have physical objects that may fall down or move in any way. You can here set up the sky texture and some other performance, some other parameters, for example, the shadow rendering and other settings. The next file is scenario. This is where all the semantic information can be found. We can set up the weather, the driving car. This is what actually makes a model to be a car. So in the scene layer, the scene XML file, we would describe how an object looks like. This would be our driving car as a box with 4 wheels. And in the scenario, we describe which box would be our car. There we can assign parameters to this box. For example, what's the maximum speed, what transition parameters we want to use, etc. This is also the point, the position where we place our traffic cars and can configure traffic lights. The next one is the interaction XML. Here we can, as the name already says, bring interaction into our simulation. We can define conditions which can be met in order to trigger any events. A list of possible events has already been shown in the morning, and we will see examples later on. And last but not least, we have the settings XML, where you can set up the camera settings, can set up the CAN client, your mirrors can be set at that position, and also the key assignment if you want to change this. So next, we are going to start to fill our model. For this reason, I show you how to start with an existing one. I will open Blender now. Yes, I know. I will show you how to do here, and if you review the video maybe at a later stage, you can try this on your own, and whenever you got problems, you can pause the video and start it again when you reach this step. So I just start to import a model. I have it in the wavefront object format here, and I store it on my desktop. So I'll just go there. And it's called tutorial object. So I just show you what this folder looks like before I load the model. It's here, tutorial object folder. And yeah, again, it's a bunch of textures, and somewhere here at the end you will see the OBJ file. So this is where the information about the model is contained. There you will find all the mesh information. We have some material file, which is the assignment of textures that can be found in this subfolder to the meshes. So I go back to Blender and try to load this model. So here's the object file, and then I click import. Here we have to use some settings. These settings are contained in the slides. So if you want to try this at home, you can have a look at the slides again. There's a screenshot of how to set up best. It's important to separate the objects by material. And I disable the clamp scaling here. And I click import. And after a short while, you should see the model. There it is. I can just add a new view here. Then you see that this model consists of several buildings. So it's not just one model at the moment. I split them by material, so you have a complete list here. For every building, it's a single mesh here, and every mesh has again its own texture. What we do next, we have it in Blender, and we could do this with whatever model we would like in all the possible formats that Blender could read. And I've installed two exporters which are needed to export our model to Opera XML. So I can, you will also find this information in the slides. These are the URLs to where you can download these exporters. There's also a detailed explanation how to install them, because it's very different from operating system, and it can be somehow tricky. So you might have to read this. Now we imported the model. I could apply some changes if needed, and after I'm finished, I can export it again. And as I have installed the exporters, I have two new entries at this position. It's the Opera scene and Opera meshes. So with which one you start is up to you. I pick now the scenes, and here I can select which parts of the model I want to include, and specify the position where I want to store. So it's important that the folder you want as output folder already exists, otherwise you will get an error message. And let's call it tutorial on my desktop, empty folder. I go back here, and now I specify this folder as target folder. Tutorial, can also give it a name. Let's call it city.scene. And as you have done this, you can click export. And now we have created the scene file we have seen before for the other models. So I have a look in my new folder, and we have the city scene here. What we need to do next is to use the other exporter for the meshes. There you again have this. It's somehow another design. It's a drop-down box here, but it's doing it in the same way. You have to select again this folder. Go back to where I have stored the other data. Was on my desktop. Folder tutorial. Yeah, you can see already the city scene is already here. And it's important, very important, that the material file we are producing here has the same prefix, the same name as the scene file already had. So I call both city, and if you have textures, be sure to take here the copy textures button. And then you can run the exporter. This sometimes will take a while. Sometimes there appear some warnings like that, but these can be skipped as long as no red errors occur. Yeah, this might take some time. The larger the model, the longer you have to wait. We had models that took almost a half an hour, or even some models even took longer. But this is already almost through. Okay, so we're done. Now we could close Blender, as we won't need it anymore. And you see our folder has filled. There are again the textures. They have just been copied. Here are mesh files. So every object, we separated them before, is now a separate XML file. And here, somewhere in between, we find our material file, which has the city material and city scene. These are two very important parts. In the city scene, we have a description of the buildings that we want in our city, and the city material is just the assignment of textures to each of these buildings. Okay. So this is also the way how to do it with the road signs. If you have created your road sign in Blender, you can use this exporter in the same way, and you will get the model as the scene file, as its material file, and all the textures. Okay, now we can proceed with the slides. This is what we already did. And the following output, as you can see in the table at the bottom, has been created. There are several mesh files, it's mesh.xml, that have been created containing the information about the mesh. One scene file, one material file, and multiple textures. For your guidance, here's the settings again. That might be helpful when you want to import objects to Blender. And I also added the most important things you have to consider here. You can use this as an orientation at home. Make sure that you name both in the same way, the scene file, the material file, and click the copy textures box, of course. Okay, now I created this scene, and here's our second task where the action from your side comes in again. We want now to add this model I just converted to our empty scene. So what we have to do is to add the following code that you can find in this slide. We have to add this code to our scene file, but you won't have to type this by hand. I've prepared an XML file where you can see this code. So just go to your USB flash drive. There you will find a folder called Material, and inside this folder, this prepared XML package is included. Just open it and try it to add to your tutorial folder. I'll do the steps now on my own to show you what you actually did. I have the same materials as you have on your flash drive. And what you had to do was to copy this section to your scene file. So I open both of them, and you had to place it somewhere inside the models element. The position is totally up to you. It's no matter. Just place it here at the end. So what have we done now? By adding this model here, we can specify an ID and the path to where we find this model. This is exactly what I exported before with my Blender export. So I stored this scene file at that position, and I can provide any ID I would like. This ID is only used if you want to reference to this model later on again. If you have some interaction, you can address these models again with this ID. If you want to place objects, if it would be a car and you would have you want to make the car to move to another position, you could address the car by the ID you specified at that point. Here we can specify some mass. If it is 0, that means it's a static object and cannot be moved. as it would make sense for the city. As otherwise, if you would specify a mass, it would be handled like a physics object and would immediately fall down. Of course, it has to be visible. Sometimes it makes sense to load invisible objects, as you can make them visible later on. The advantage is that you have the loading process initially, and it's less consuming, less power consuming as if you would do this during runtime, as it might stop the simulation or hold it a little while. So you could do this at the beginning, make all the objects invisible, and only make them visible if needed. And yeah, here three more important transformation settings: scale, rotation, and translation. So as we are moving in a 3D coordinate space, all of these entries, every one represents one axis. So it's the X, Y, and Z axis here. And you can scale objects in these 3 dimensions. In this case, we just make the object smaller by 40% from its original size. So we scale in all 3 dimensions with factor 0.4. This is because the model we created with City Engine was simply too large, and when you load it to the scene and place your car, you will see the street is very wide, and you will lose the car in the city. Rotation, in this case, we rotated our model by 90 degrees around the up axis. So the first axis is the one facing from left to right. The second one is facing up, and the last one is facing from behind towards you. So if you need to rotate around any of these axes, you can specify the values in degrees at that position. And translation, you can specify an absolute value where in your 3D space you want to set the model to. The unit is meters, so if you, let's say, set this value to 10, you would lift your model 10 meters up. So now I store this, and when I reload the simulator, the model should be there. Maybe I just close all the other windows. This might confuse too much. I can also close Blender. Then I restart the simulation. And our tutorial map should now show up. Okay, we can move around. You will see everything is still the same. We have car. Here's the grass plane we had before. Sky texture, and the thing we've changed from a distance is that we have added this city model, which is exactly what I before exported from Blender. The distance, you see that's not that big. Okay. Yeah, you can see here a little bit from the top. We have with another tool would have the ability to fly through the scene, but very often inside the simulation. Okay. So this was task 2. Now the next step, we are applying filters. If you remember, you started your simulation. It showed the picture on the left. There was this blurry line in the center of the road. And at the example of the anisotropic filtering, I'll show you how to remove these blurry effects. So I do this, and you may follow me if you like. First of all, we can do this together. As this is not a big deal. We go to the assets folder again, and there we select the scenes subfolder. Next is tutorial, and there's a whole bunch of textures, and somewhere in these textures there is a material file. It's called city.material. We open this with a text editor, and it should look like that. So best would be to search for lane. This is the material that we want to change now. There's a whole bunch of materials included. It's all the buildings, all the facades, the street. So we will find it better if we search for. And there I've found the lane. And you can see there's all the lighting information for this model. You can even have transparencies to set up here. And we have the texture that is applied to a certain mesh. In our case, it would be, it's called street one lane stripes PNG. And to this texture, we can add our filter. I just will have to look up how it's correctly spelled. Yeah, the filter is named max underscore anisotropy, and the number behind specifies how intensive the filtering will be applied. The higher the number, the better the result, but it's also much more power consuming. So I wouldn't do this in general for all textures, only for those who have very strange angles, as for example in the distant road, you have a very steep angle. Then I would recommend to apply this filtering. Then we can store this material file and restart the simulation again. Which should result in a better looking line in the center. So we're heading to the next task. We have several of them. You have seen the texture behind. Didn't maybe look that natural, or you have your own texture that you want to apply. And now we're looking how to do. This is a rather simple task. You have to go to your yeah, I've just seen there's a mistake on my slide. Sorry for that. This path is wrong. Just correct that. Okay, now it's correct. So you can again try on your own to go to this scene file and find the sky texture element, and you just have to change the path, which is at the moment set to bright sky, and go there and just change this bright sky into mountain.dds. And if you start the simulator again, you should see the sky texture changed.